Hi everyone, welcome to Simplilearn. Today, we will learn the basics of SQL Server. SQL Server is a powerful relational database management system developed by the Microsoft, which is widely used for managing and storing the data. Its benefits include high scalability, robust security features, and seamless integration with other Microsoft tools and technologies. SQL Server provides efficient data management through advanced features like indexing, full text search, and in memory processing. It also offers excellent support for large datasets, making it ideal for enterprise applications. The built in business intelligence tools help organizations gain valuable insights from their data. SQL Server's high availability and disaster recovery features ensure continuous operations with minimal downtime. With strong data integrity and transactional support, it ensures reliable and consistent data management across all applications. That said, if these are the type of videos you'd like to watch, then hit that like and subscribe buttons and the bell icon to get notified. So in this session for today, which is SQL Server tutorial, we will cover the SQL basics. That is how to create a table, how to insert data, how to retrieve the data from the tables, etc. And apart from that, we will also go through some of the other fundamentals of SQL basics, which include sorting in SQL Server. And followed by that, we will also go through the group by and order by sequences in SQL Server. Next ahead, we will also learn another important part, which is conditional statements, which includes case statements in SQL. Proceeding ahead, we will get into another segment of today's session, which is about joins in SQL, where we will be combining two or more tables in SQL Server. Followed by that, we have the next part of today's session, which is all about the having clause in SQL Server. Next, we will proceed with learning the next part, which is about the between operator in SQL Server. And followed by that, we will get ahead with pattern matching in SQL Server. Next, we will cover the time and date functions available in SQL Server. And after that, we will proceed with temp, which is temporary tables in SQL Server. And proceeding ahead, we have the most important part, which is about the common table expressions in SQL Server. And followed by that, we have the last part in SQL Server tutorial, which is about creating views and executing a query to extract the data present in a view in SQL. So far, so good. So these are the foundational skills in SQL Server that you need to get before becoming a pro in SQL Server. So this particular tutorial will discuss the major foundation skills, the fundamental skills, the basics of SQL Server and its operations. Now, without further delay, let's get started with one of the compilers which can help us execute the SQL Server queries. So we are on one of the SQL Server compilers available online. In case if you are facing any difficulties setting up the SQL Server Management Studio in your PC, then you can come up with this one. And we have also set a particular tutorial where you can learn how to download and install SQL Server Management Studio and how to configure your SQL Server Management Studio. And the link to that particular tutorial will be dropped in the description box below. Make sure to refer that in case if you wanted to execute these same codes in SQL Server Management Studio. Right? So first we will be dealing with two different data tables. We will be dealing with customer data and dealership data. So the first table will be about the customer data, where we will be having about the order ID, order date, delivery date, dealership pin code, product category, and car fuel type, etc. Followed by that, we will insert some rows into that particular customer table, about 15 to 20 tables. And after that, we have a dealership database where we will be having order date, state, region, customer ID, customer name, primary key, foreign key, etc. And we will be inserting about 20 entries into that particular table. Don't worry if you have more than 20 entries. In case if you have more than 20 entries, let's say about 2000 entries or 20,000 entries, it's not at all a big deal if you're working on SQL Server Studio, right? There you can use the wizard to just ingest the data from your source into the SQL Server, right? You can use SSIS tool to import all that data and you're good to go. You don't have to manually create the data and you don't have to manually insert the data. Just for the sake of learning the basic process of how to create a data table and how to insert the data table, you're going through this particular procedure. So far so good. So we have also inserted the data in the next data table, which is our dealership data. And now let's query the data from our tables. And now let's select the execute data. There you go. We have the data table right over here. And let's copy this query and paste it to query the data from the customer table as well. So instead of dealership, we will be writing down customer. So if you observe closely, I'm using uppercase for keywords like select and from, and sentence case or lowercase for the variables, the table names, etc. So that there's a difference between the keyword as well as the regular variables. There you go. We have executed the customer data, and here we have it. The order ID, order date, delivery date, days to deliver, category, and etc. Now, let's mention the use cases, correct? So, let's use double quotes, or maybe we can also use hashtag along with the pipe symbol here or the slash symbol here, and write the use cases, and then proceed with executing the codes or queries. So the first use case is, let's try to filter customers from specific regions. And now let's close this particular comment, proceed with writing the query. So we will be using select keyword, and we want customers from a specific region, right? So let's write down the customer name. So I think the customer name is not mentioned in the customer data, but instead of customer name, we have a order ID. So let's extract the order ID, not a problem. Select order ID and dealership name, permanent state, and the important part, which is about the region and what product did they, and what's the revenue that the dealership has extracted out of that particular customer from the table customer. Next line is about join dealership. So we will be using join table dealership, the keyword. So we have one common keyword in between both the tables, which is about the order ID, which is equals to order ID. So this is not done here. Since we are clubbing both the tables, we need to specify the tables here. So dealership dot order ID and customer dot order ID, so that the SQL Server will identify we are trying to map two different tables, and we are trying to combine and extract the data. Now we are trying to filter out customers from a specific region, correct? Now we will be using where clause to specify that particular region. So let's go with West region, correct? Since we are using the text format here, so it's better we choose double quotes, correct? Now let's run this query. Let's give it a next try. Ambiguous order ID. So let's do one thing. We will pull customer table name here so that it's no more ambiguous. There you go. So the thing is, we have order ID in both the tables, customer table and dealership table. So SQL Server got confused here, which particular table you want me to extract order ID from. So if you mention customer table or dealership table, it will choose a specific table and extract that particular column. Now we have the order ID, dealership, and all the members that we selected are from the West region, if you check here. Now let's proceed with the second use case of today's session. Okay, let's continue with the same here so that it is clearly visible for us. Now, let's sort, we're using the sort command here, products based on the revenue. So it's like maybe highest revenue should be in the top or lowest revenue should be in the top. Let's go with the highest revenue, okay? Sort products based on or based by revenue. We will write the command here itself. We will go with some columns. I would like to have product here, so I'll eliminate everything else, and the product will be here. and I want the revenue as well. Now I don't want the revenue, I want the total revenue. So if you're looking for total, then you will be going with the function or aggregate function, which is sum, right? I want the sum of all the revenues that particular product has earned throughout the years or that particular financial year. From which table? So I have both product and revenue in the customer table itself. So I'll go with customer table itself. I don't want to join anything here. I'll eliminate the join command, and instead of region or instead of where command, I would use the group by command here. Group by product, and it is not done so far. We want to order it, so we want to keep it in descending order so that the highest grossing product is on the top and the lowest grossing product is on the bottom, right? So that we can also make sure that our inventory is filled with those products which are giving us high revenue. So we will be using order by total revenue, right? So we can give it an alias as total revenue. Right now we can use this particular term here, order by total revenue, descending. DESC is good enough. Now this is how you will sort the products. Now let's execute this particular query. There you go. So the car model T, okay, yeah. So the car model J is giving us the highest revenue. Next is followed by T, M, and S and G. So we are not mentioning specific, if you go back to the table, here we are not mentioning the actual car brands and actual car names, so that we don't want any copyrights to be faced. So we are just mentioning some random names, not to be too specific there. Now, let's proceed with our next query for the session, where we want to group by state and calculate total revenue. Let's edit the same comment here. Don't worry, if you want this demo document, we will also link that demo document with all edit and view rights, so that all the viewers can have a quick glance and try to execute these queries in their own local systems. Okay. Now let me type down group by state and calculate total revenue. There you go. Now let's try to edit the same query. Now we want state-wise revenue, and we want from customer table, right? We want to join a dealership for this particular one, because dealership is the one which has some details for it. So the state data, right here you can see we have inserted state data California, Texas. So we want the state data, so it is present in dealership table. So we also want to perform a join there. No worries, let's edit the same query here. So we want, instead of product, we want state, and instead of sum of revenue, yeah, we want revenue. So we will keep it as it is, total revenue as total revenue, sum of revenue as total revenue from customer table, and we want to perform a join operation. So let's create some space. Join dealership. Okay, let's copy the name so that we don't make any confusions here. Dealership, sorry, here. Don't worry, we'll make some edits down the line. Dealership on order ID. So let's go with the order ID, which is available here. Order ID equals to order ID. Remember the first step we did. Eliminate the confusions by mentioning the table names, dot column name, and customer name. The customer table name, dot column name on, yeah, we did it on dealership dot order ID equals to customer dot order ID. Now we will be performing the group by operation. We don't want the order by here. Group by state. Of course, in case if you wanted to, order by the highest grossing state, you could have used order by there. But so far, according to the use case, we don't want that. So let's continue with the same execution here. Click execute, and you will be having the answer here. So based on the states, you have their respective revenues. There you go. Now let's proceed with the next use case for today's discussion, which is about using a conditional statement like case. Using case, query, or clause for custom calculations. We'll perform some customized calculations. Now let's say we wanted to find out a product which is giving revenue greater than 10,000 as high revenue. Let's say we have revenues in terms of thousands of dollars, and let's have a benchmark like $10,000. And $10,000 is the minimum revenue you wanted to extract out of that product. And if it is not yielding at least 10,000 for your dealership, then that product is not selling much. So that you can at least make some space in your dealership so that you can import some products which are giving you highest revenue, right? So we want to find out those products which are giving us revenue between 5,000 to 10,000 as medium revenue, and less than 5,000 as low revenue, and greater than 10,000 as high revenue. You understood the game, right? So we have three segments: high revenue, medium, okay type of revenue, and least revenue products, so that you can eliminate the least revenue products out of your inventory. Now we want order ID. So copy the order ID from here and paste it here. So we are looking for order ID, and we are also looking for product. So we don't want sum of revenue here. Let's eliminate this one, and instead of that, let's add product. From we'll extract this from, okay, before from, this from statement will be at the last. Here we will begin with a use case, right? Let's type case. Now, when a specific product or revenue, okay, let's revenue is greater than $10,000, then let's not use sentence case, let's use keywords in caps. Then mention it as high or high revenue. Let's copy paste the same code here. When revenue is between 5,000, and we will be using an AND operator here, then term it as, okay, we don't want alter, average revenue or medium revenue, and copy paste the same here. Remove the alter. And revenue is less than, okay, I think we don't want to use this. Instead of this, we can just place else, right? So we will place else. It should be termed as low revenue or least revenue. Let's go with low revenue. There you go. And now, from which table you want to extract that? I want to extract all this data from customer table. So everything will go off apart from that. Now let's execute this particular code. Let's see if we get any errors. Incorrect syntax for case. I think we made some mistake here. Okay, we forgot the comma here. Should have mentioned a comma. And yeah, so the thing is, we by mistake chose the alter from suggestions, alter keyword from suggestions. So far we missed a comma and alter from suggestions. I think it's everything good to go. Let's try to execute, and if it faces some issues, no problem, we'll try to resolve it in a different way. So incorrect, we missed to write the end. Okay, we did not end the case. Okay, fine, not a problem. End as, okay, let's term it as the entire table as revenue category. Since we are splitting into three categories, revenue categories. There you go. So this is the way to learn. Make some mistakes so that you can learn in a better way. For the next time, you'll never make a mistake. So far so good. So we have all the car models have categorized into the revenue categories: high revenue, low revenue. So far we have all the cars in high revenue. Not a bad deal. I think all the cars are performing really well. Maybe if we change the numbers a little bit, maybe if we take up 1 lakh in place of 10,000, then maybe we can get a couple of cars. But so far so good. This is how the query works. Now let's switch to our next query, next use case, where we will be combining data from multiple tables using a join. We already did that, but still, for the sake of learning experience, we will also perform that particular operation. So we will be naming this particular use case as combine data from multiple tables using a join. So far you have already have a good experience on how joins work, but still we will try to do that. Now we will use customer table here, customer table dot order ID, and we want customer table dot product and customer dot revenue. And, let's also say take some data from dealership. So we already know that some data of states is in dealership. So we'll also take the dealership data. So dealership dot state. We'll also take the region, dealership dot region from customer table. Let's eliminate the case statement from customer, and we want to join. Let's push this to the first line so that we don't have confusion how and where the query is going on. So here I want to join. So the second line is all about join dealership. So let's copy this. We are combining dealership with customer on order ID. In the same way, we will take order ID equals to order ID. Now, which order ID is equals to which order ID? The first table customer.order ID is equals to the second table dealership order ID, so that SQL Server understands which columns from which tables are being joined here for what reason. Right, so far so good. We have given the columns that we want to have in our output, which are these columns, and we are joining two tables based on certain criteria. But now maybe we can specifically mention some more data. Let's say we already mentioned some query where we wanted the data for a specific region. Let's try to continue that, where region is equals to west. There you go. Let's close the single quote or double quote. Now what happens is it is trying to give us the details of customer order ID, product, revenue, state, region from customer table, and we are going to also execute or extract the details of state and region from the dealership table, and we are trying to join to extract those data with dealership data, and we are specifically extracting the data where the region is west. Let's execute the data. Don't worry if we find any errors in this particular code. There you go, we have the result. So we have all the details from the west region. There you go. Let me expand this so that we have a better view. Anyways, it's okay. Now let's go with the sixth query for today's session, where we will be executing a query based on having clause in SQL Server, and we will try to filter out some states. Only show the states where total revenue is greater than 50,000, just like we discussed before. We initially used a case statement with $10,000 at least revenue, but now let's increase the number to 50,000, and we want those states which are giving us minimum 50,000 revenue. So let's rename the use case here. We will try to name it as filter data or groups with having clause. Okay, so we want state. We have state here, and let's also count as total orders. So order ID. So customer.order ID will be now count of total orders. So the count will be the aggregation function here, count total order IDs, and we can name it as total orders. And do we have revenue? Yes, we have revenue. And let's also remove the product. I don't think we might need a product here. And the aggregation will be sum aggregation here, sum of revenue. And I don't think we need to specifically mention it here. But anyways, we'll keep state first. Copy state and drop it here. We want state count of orders as orders and sum revenue as total revenue. What this does is it will give a clarity, right? So instead of if I don't alias it, what it shows is sum of revenue. And for a generic person, it might not be as helpful as a data engineer can, right? For a data engineer or data analyst, he can totally understand by just reading the aggregation function. So we are counting the orders here, we are getting the sum of revenue here. But for a mere person who just wants to see the report, the business guy who just wants to see the report, for him, total orders or total revenue is a simplest language that he can understand, correct? Now we are extracting this data from customer, and we will join dealership again, okay, because we also want to extract the state, right? So we did not mention the state here. We can mention the state anyway. Okay, we did mention the state. So since we have the state column, for extracting state details, we'll anyway go for the dealership. So we are already joined dealership data with customer data. And let's do a group by function here. Group by region, group by state actually. And now the condition, having sum of revenue at least or greater than 50,000. So we will go with the having clause here, and the sum of revenue, or you can also use the alias name, total revenue greater than $50,000. So let's execute this query and see if the alias works or not. Okay, I think alias will not work here. In case of alias, let's go with the actual term and place it over here. And now let's try to execute this if it works or not. Okay, we mentioned two things here, region and the state. So we just wanted state there, not region. I think this should solve the issue. 20 rows affected, ambiguous column, order ID. Now we will, let's say, take customer name and place it here. Or I think a dealership would be the best because we have the details of orders here. No. Customer table has the order details. So let's keep it that way. There you go. So we have so many number of states which have revenue greater than 50,000. So these are the outputs. There you go. Now let's proceed with the next query where we will be using the range function, which is also known as the between function in SQL Server. So let's name the comment as using the range function. Let's not capitalize it. Using the range function named between. So between is the keyword, right? Now let's build a use case. Let's identify couple of states. We will use the same query, will not make some major differences here. So we want to identify a couple of states whose revenue is greater than 50,000 but less than 1 lakh, right? This makes a good use case for that implementation of between function. We will keep all the columns as they are, and maybe we can also include a couple of columns, maybe product as well, and we will join two tables. Now I think we don't need a group by here, but in place of group by and in place of having, we will specify where sum. So to use where clause, so I mean to use between clause, having is not the right keyword, where is the right keyword. So sum of revenue should be, in place of the symbol between, you take the suggestions, and 1 lakh. Yeah, this is 1, 2, 3, 4, 5 zeros. So this is the right way. Now let's try to execute if it works or not. If there is some error, yeah, there is some error. An aggregate may not appear where clause unless it is subsidiary. Okay, contain having clauses select. I think this is the place where we can go with the alias name. Let's try that. Or if alias does not work, then we will go with revenue. Okay, let's simplify this. Let's not go with the join statement here. Let's eliminate the join. We shall just simplify. We don't want state. We want, okay, let's not count this. There was no need for counting. I think that was one error. We will go with order ID as total order. We don't want this. And anyways, we want to take a look at the product and dealership name as well. And we also want revenue from customer table, where revenue is between these numbers. Let's try to simplify and run this query. I think it should work. Yeah, it worked. So these are the dealerships and products which yield in revenue between 50,000 to 1 lakh, right? So this is the best way to use it. So we had some extra aggregate functions which complicated the query. No problem. Now let's go with some pattern matching. Sometimes, let's say we are looking for sales from California or something like that, or we are looking for some car model, correct? And we don't know the full name, or we might have a spelling mistake, right? We have California here, but let's say we don't know the spelling of California, but we know the first 3 or 4 letters of California, right? So in those instances, what you can do is try to match the pattern that we have in our hand with the pattern which is available in the data table, and wherever it finds a match, it extracts those rows. So this is how the pattern matching works. Now let's execute a query for a better understanding. Let's keep the same query. Let's change the use case here using the pattern matching in SQL Server. So we will have order ID as it is, dealership name as it is, and product as it is from customer table, where product, so let's copy this and paste it here, like, or I like is the opposite, so let's go with like. Car model, let's check with the car models first. So all car models are the same. So maybe if we go with the fuel type, I think fuel type will help, because all the car models have the keyword car model, and the only thing is an alphabet M, etc. So it doesn't make sense for us to execute the like operator here. So instead of product, let's keep fuel type like hybrid, correct? Let's go with the hybrid one. So we will take only the first 4 letters. Let's imagine we don't know the full spelling of hybrid. So if the pattern is like, and since it's a text, we will use single quotes or double quotes. If the pattern HYBR matches with the elements or the column present in the customer data, it will pull all those columns or rows. Now let's execute this. So there you go. Okay, we missed one important thing. We missed to include the percentage. This percentage symbol will make SQL Server understand that the text should have HYBR, and after that anything is accepted. So anything which has a beginning with HYBR should be pulled out, right? Now let's execute once again and see the data. There you go. You have it. Correct? So remember the symbol percentage, right? And in case if you didn't knew the hybrid, let's say, it has some YBR in its format, right? It has some YBR in the format. Anything before YBR is okay, anything after YBR is okay. Again, it will yield the same result, hybrid. There you go. But in case if you wanted to change, let's write the name of petrol. I don't know the spelling of petrol, so let's say PEET. So let's imagine I don't know the name of petrol, so instead of petrol, I'm eliminating P and I'm writing PETR and anything after that. Now let's run this query and see the output. There you go. So we have all the vehicles which are of fuel type petrol. So this is how you can use pattern matching in SQL Server. Now let's perform some calculations with dates, right? So we'll perform some date and time calculations. Let's rename the comment as date and time functions, date and time, and some math calcs. Now let's say you are the owner of dealership, and let's say for a specific car you are losing customers. Initially it used to perform very good, like many customers used to come for that specific car, And right now that specific car is receiving less orders, and you wanted to find out what is the reason behind it. And after a general survey, you come to know that the number of days you took to deliver that car is growing. Let's say earlier you used to deliver that car in 2 days, but right now you're taking like 2 months to deliver that car, right? So that might be the reason. But you wanted to make sure that you have a solid proof that you have the number of days that you're looking at to show your sales team why is so many number of days is being taken to deliver a car. Now for that, let's go with select order ID, order date. You want order date for it. Now you can simply copy the order date here and paste it there. And you also want the delivery date and copy that and paste it there. Remember, these date and order date and delivery date are of date data type. And now you want to calculate the difference. So for that, you use a function called datedif or dateddiff. So there's two ways of calling it. So if you prefer calling it as date, right, diff, or a few call it as dated diff. Okay, so there's two ways of calling that function. So I prefer to call date diff because date difference. So date diff, comma, sorry, open bracket. So I want to provide some details here. So I want to provide a day. I want to count the days, right? So I want the count of days. I'm mentioning day and order date. Difference between the order date and the delivery date. You can specify that using a comma. So I want the difference between these two. In case if you want to alias it, you can also do that. Days to deliver from customer, and we don't want this. Simply place a semicolon there. And now just copy this and execute. There you go. Now you have the number of days that you or your sales team is taking to deliver the vehicles. So, and on an average, you're taking about 10 days to deliver. Now you can prove this to your sales team and let them know this is not good. You want to have at least a minimum 4 to 5 days or 2 to 3 days to deliver a vehicle. If this goes on, the sales might drop and it might be a little problematic, right? Now let's proceed with the next use case of today's session about the temporary tables. Now, why temporary tables? So there comes a situation where you have to just run some numbers, run something very not too critical, but you just wanted to do that. So in such scenarios, what you can do is you don't want to harm the original table. So what you can do is you can create a temporary table or a copy of that table, which is somewhere in the intermediate memory storage. And as soon as you close the studio, it fades away and nothing happens to your original data table. So that is where the temporary tables come into picture. Now let's create a simple use case for that particular temporary tables, right? So we will be selecting order ID, and let's also take product, and let's also take revenue into temp order. Yeah, it's enough. Temp order tables. I don't want that. Temp order, and I don't want to alias it. And from which table are you taking that? I'm taking that from customers. You can either choose to keep it in a new line, or you can keep it in a same line. But I want to keep it in a new line. From customers, and where revenue is, I said you right, you wanted to just explore a few things which is not too mandatory, but you just want to take a look at it. That's where you take the option of creating temporary tables. And I want to find out which are those products which are giving us revenue greater than 1 2 3 4 5 $1 lakh, right? Now let's run this. It's done, but we don't know where it is. So what you can do is you just write up simple select query, select star from your temporary table. Close the query and run it. There you go. So far there are no such products which are giving us greater than 1 lakh sales about that single product. Invalid object name, temp order. Okay, there might be some error about this particular query. Let's try to reduce the number. Did we miss anything? Where revenue is greater than, okay, this is a number, we don't want semicolon there. Okay, we missed a semicolon here. Let's run this, execute. Let's keep it as 10,000. Okay, so there was no certain product which was above 1 lakh. That was a problem. Okay, so these are the products which are giving us 10,000 sales at least. Not a problem. Now let's proceed with the next important part of today's session, which is about the common table expressions. So remember, common table expressions are also known as CTEs, play a very major role in real-time data analytics. Right, so let's have a sample of that. Let's create a common table expression, which is rather simple, and just learn how technically it works. Right, so the only difference is the CTEs start with a keyword named as with, and after that you can term your common table as some data, so or some name. I'll give it as sales data as, and open a bracket, and inside this bracket is where you write your actual query. Now let's organize a few things. I don't want the temp order table here. I don't want temp order here. Okay, I want to extract a few columns. I want maybe state, and I maybe want I don't want order ID. I want revenue. Maybe revenue is good. So let's sum the revenue and term it as total revenue from customer. And now let's proceed with a join command where we will be joining dealership data. Let's copy the dealership data table name. We will be joining based on the order ID that is common. So maybe order ID. Copy the order ID is equals to order ID. And which order ID are you talking about? I'm talking about customer's order ID and dealership data order ID. So we need to mention that on dealership.order ID and customer.order ID. Group by state. So since we took state as well, we can use a group by function here. And this is not the end of everything, so semicolon may have to wait. So this is the first part. Now using this particular CTE, this entire term is CTE. So the output of this particular query will be stored in sales data. Now we will make use of this CTE or sales data term to extract a few more queries. So we will be writing another select statement. Select state from, okay, let's also take the total revenue which we created here. Let's take that same term here so that we don't make a mistake. From the CTE which we created very recently, which happens to be the sales data, where total revenue is crossing something about $50,000. And now is the semicolon. Let's try to execute this. There you go. So a few regions or a few states and total revenue which are exceeding $50,000 are, there you go. And with that, we have reached to the end of this session on SQL Server tutorial. Should you have any queries regarding any of the topics covered in this session, or if you require the code documentation or the data tables that we used in this session, or apart from that, any other resource that is being used in this session, then please feel free to let us know in the comment section below, and our team of experts will be happy to resolve all the queries at the earliest. Until next time, thank you for watching and stay tuned for more from Simplilearn.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.